Welcome to this Getting Started guide of Shimmer++. This video will cover creating a custom QML type that interacts with the Shimmer ecosystem. We will go to the building and installing of this QML module. We also build an example application that uses this module, and we will play this simple NFT game that is the example application that we just built. Let's go. Shimmer++ allows to run applications on different platforms. Platforms like desktop, browser, embedded device, and mobile. The development and deployment become smooth thanks to CMake and Qt. Let's build the QML module from source. Go to the GitHub repo and clone the repo. Create a build directory and from there configure the CMake project. Here we are using the Qt CMake script from Qt 6.7 and setting the installation tree in the folder called install at the same level that the build folder. CMake is complaining that it cannot find a WebSocket and MQTT component of the Qt package. Yes, I don't have those installed. But in this case, our CMake project will download these components and build them. It is recommended to have those components installed on the system. The project builds the QML module library and also an example application that uses the module. If we list the content of the build folder, we can see the module plugin library called libnftmonitorplugin.so and also the backing target library called libnftmonitor.so. Let's run the example application. The application cannot find the module we created, although the backing target is explicitly linked to it. In this case, the app should load the module at runtime by setting the QML import path variable, pointing to the directory where the plugin folder is, in this case, the build directory. As you can see, the app now works, so we managed to compile the QML module and also an example application from source. A nice thing is to install the module library and CMake package so that other CMake projects can use it. From the build directory we run this command and all the headers and libraries are copied to the installation tree. So other CMake projects can now use a find package function to link to this module. For example, the same example application project can be built using fetch content and find package methods of CMake. If we check the fetch content CMake list on the example source, we see this part that will try to find the NFT monitor package. If the package is not found, CMake will download the sources from GitHub and build the package. In our case, we already installed the package NFT Monitor. Let's create a build directory only for building the application. So let's change the CMake list.txt of the example app. And configure only the example application project. We pass the CMake prefix path variable equal to the installation directory of our module, so CMake will be able to find the NFT monitor package. The build directory does not have any depths folder, so no code was downloaded from GitHub and is using the module in the installation folder. Let's build again the example application, but in this case using the module that we already installed. As you can see, we get the same error, so we just need to set the QML import path variable. And the application works. In this case, we use an already installed module to build the application. Let's now not set the CMake prefix path variable. So the example project will download the dependencies from GitHub. Now, as you can see, there is this dep folder with all the downloaded source code of the dependencies, like in case the module library NFT monitor. Let's build again the application. This time the application did not complain about not finding the module. It could be that it's loading the module we previously installed, but now you know the procedure to load the module at runtime. Let's do even more. We will download the build module from the GitHub releases and use it in the application. These releases are created by the GitHub runners. You can always choose not to trust them and build it from source. I will download those for Linux. We can see it has the same structure that our installed module library. So we can do the same configure CMake to find the NFT monitor package for the download GitHub releases. Again, the same complaint. Now the application cannot find the plugin library. In Linux, this is solved by setting LE library path variable. We also have to add the path to the WebSocket library that comes from Qt. And finally, the application works. I want to show you now the example application working. For that, we need to mint some NFTs. I will be using this repo here to mint some NFT. I could use the browser application, but I do not have Shimmer mainnet nodes that do proof of work for the client, and the nodes from DLT Green do proof of work but doesn't have well configured the AP request from browsers. So I will use the node from DLT Green but from the desktop application. Let's download the latest release for Linux of this program called NFT Minter. When try to run the app, now we know how to solve this. We have the desktop application working. To use the application, one needs to transfer some glows. With this small amount, you are supporting the development on Shimmer. right now I'm transferring 1000 glows to that address with that tag using Firefly. Okay, it seems the transaction is complete. Let's use the DLT green node. Create our NFT like a digital collectible using the TIP27 schema. Use a sample image that I have uploaded to GitHub. I cannot use any image on the web because we will use the browser to run the application, so the courses are well set for GitHub. Let's put PNG here. To mint the NFT, I need to transfer some glows to the application. It is good to notice that this application is running locally on your browser. No server has access to your seeds or funds. Also, the source code of the application is open and the application was built automatically from that code on GitHub runners. Right now I am transferring funds to the application address using TanglePay mobile wallet. In the meantime, let's copy the seed of the application just in case. I can't even show you the seed because I will never use this seed again. As you can see, the funds have arrived, so we can mint. Now let's transfer all the assets back to TanglePay. One can double check on the Explorer that there are not funds linked to that address. I have transferred that NFT from TanglePay to Firefly because I want to send it back to TanglePay but with a metadata. So if I were Philo, I will just transfer my NFT to an address I control and add to the metadata of the output my name alias, so I can play and be recognizable by my address in the simple NFT game that we did. So now the Philo address is set up. Okay, here we go. Let's run the simple NFT game application. I will put the Philo address on the left and the STRV dash address on the right. For this app to work, we do not need proof of work, so we can use the IOTA Foundation nodes. On the left is shown the name on the metadata of the NFT open. It calculates the attack coefficient and shows the image of the immutable metadata. On the right, it shows the pictures and an attack coefficient that is the same for NFT outputs issued by the developers, in this case STRV dash. The attack coefficient is the highest. Also, the game shows who is the winner based on the attack coefficients. You can mint your own NFTs and use it on the application. Take into account this is a simple example. You can fix or improve the interface by changing the source code. More complicated logic can be done using NFT in games. there are some bugs on this application. Let's see it. If we change the address on the left, the name gets updated to Philo, but the attack and the picture does not. If we check the browser console, the QML type prints the issuer, the URI of the picture used, the name, and the attack coefficient when the issuer is changed. So this is a bug of the application. You can write on the comments of the video the simplest solution for this bug of the application. I will be giving 2 NFTs issued by Esther Vitesh to the 2 best answers on the comments or the pull request to the repo fixing the bug. 2 NFTs with the corresponding storage deposit. The owners of these NFTs will have free access to all the products of Esther Vitesh. For the worst answer, I will give the other NFT, the one not issued by Esther Vitesh. I will wait 30 days to choose the winners. Also remember to put your address on the comments. And this is all for this video. Make sure to check the Shimmer++ blog for more information. The link will be on the description. Remember that this is a community effort, so try it and improve it. In the following videos, I will explain how to use the Shimmer++ libraries and these custom QML types to create multi-platform applications. With the same code, we will deploy the application in major desktop platform, browsers, mobile and embedded device. Applications that interact with the Shimmer ecosystem. So subscribe to this channel on my Twitter account to get the notification. See you in the next one.